This is lesson 5.1, solving inequalities by addition and subtraction. Your objectives are to solve linear inequalities by using addition and solve linear inequalities by using subtraction. So just like in equations, with inequalities, you can add the same thing to each side and you can subtract the same thing from each side. When you graph an inequality, make sure the variable is on the left of the inequality when it's solved. And then on the number line, you will have the solution number that will either be included or not included, and it will be shaded either to the left or to the right. The reason it graphs this way is because it's not just one number that's the solution. It's a range of numbers. All numbers less than a number or all numbers greater than a number. If the variable is less than or greater than the number, then the number is not included in the solution. That's why the circle on that number would be open, to show that it's not included. If it's less than or equal or greater than or equal to, then the number is included, and we'll get a closed circle for that point. Greater than shades to the right, and less than shades to the left, because the greater numbers exist to the right on the number line, and the lesser numbers exist to the left. Solve each inequality, and then we'll graph it on the number line. Remember, with inequalities, the variable must end up on the left. Number 1. T minus 12 is greater than or equal to 16. Well, first let's solve for t. So we'll add 12 to each side. The 12s cancel on the left, and you get t is greater than or equal to 28. When you write the solution, you write it in this form. An open bracket, t, and then that bar means such that t is greater than or equal to 28. What that says is the solution is all t such that t is greater than or equal to 28. Now 28 is my important number. Let's check on the number line and show why the system of graphing works. If we check a number to the left of 28, like 26, substitute 26 in. 26 minus 12 is greater than or equal to 16. We're just substituting 26 in for t in the original inequality. Well, 14 greater than or equal to 16? No. So the numbers to the left of 28 are not shaded in. What about the number 28? 28 minus 12 greater than or equal to 16? Is 16 greater than or equal to 16? It's equal to it. So yes, 28 is included. That's why we will get a closed circle on 28. Then a number to the right, like 30. 30 minus 12 greater than or equal to 16? Is 18 greater than or equal to 16? Yes, it is. So the numbers to the right of 28 are also shaded in. Close circle on 28, shaded to the right, and fill in the arrowhead. Number 2. N minus 12 is less than 6. Well, 12 is being subtracted, so we will add it to both sides. 12's cancel, and 6 plus 12 is 18. So the solution is all n such that n is less than 18. 18 is our important number. Since n is less than 18, but it's not equal to 18, it gets an open circle, and the lesser numbers are shaded to the left. Open circle on 18, shaded to the left. Number 3. 6 is less than or equal to g minus 3. Well, the 3 is being subtracted, so let's add it to both sides. On the left, 6 plus 3 is 9. And on the right, the 3's cancel out. And remember, write the final answer with the variable on the left. Since 9 is less than or equal to g, if we write the g first, we're going to have to flip the whole thing around. G is greater than or equal to 9. It makes sense. The mouth on the greater than and less than symbol is open to the g in each of those statements. Make sure that it stays that way. If you switch an inequality around where the variable was on one side and you turn it around to put it on the other side, make sure you also turn around the inequality sign. So the solution is all g such that g is greater than or equal to 9. Since it's equal to 9, then there's a closed circle on 9, and the greater numbers are shaded to the right. Solve each inequality. Number 7. Negative 3x is less than or equal to 8 minus 4x. Well, there's variables on both sides, so let's move them all to one side. It's best to move the smaller amount to where the larger amount is. Since negative 3x is more than negative 4x, let's move the negative 4x. It's a negative 4x, so let's add 4x to both sides. Since it's being subtracted, we will add it. On the left, negative 3x plus 4x is 1x, or just x, less than or equal to. And negative 4x plus 4x cancels out, leaving an 8. All x such that x is less than or equal to 8. Get the variables all on one side and move the smaller amount of variables to where the larger amount is. That's usually the easiest way to do it. Since the negative 4x was smaller than negative 3x, we move the negative 4x. Number 8. 0.6n is greater than or equal to 12 minus 0.4n. Well, the 0.4n is smaller, so let's move it to the left. It's being subtracted, so let's add it to both sides. 0.6n plus 0.4n is 1n, or just n, greater than or equal to 12, and negative 0.4n plus 0.4n cancels out. So the solution, all n, such that n is greater than or equal to 12. Number 9. Negative 8k minus 12 is less than negative 9k. Well, you have variables on both sides, so let's get them on one side. The negative 9k is smaller than the negative 8k, so let's move it. Since it's a negative 9k, we'll do the opposite and add 9k to both sides. Remember, it's sometimes easier if you move the smaller amount of variables to the other side. Negative 8k plus 9k is 1k, or just k, minus 12, less than negative 9k plus 9k is 0. Now move the 12. It's being subtracted, so let's do the opposite and add it to both sides. You get k is less than 12, with a final answer of all k such that k is less than 12. Number 11. Z minus 1/3 is less than or equal to 4/3. Well, 1/3 is being subtracted, so let's do the opposite and add 1/3 to each side. The 1/3 cancel on the left. 4/3 plus 1/3 is 5/3. So the solution is all z such that z is less than or equal to 5/3. Define a variable, write an inequality, and solve. Number 13. A number decreased by 4 is less than 14. Well, our variable will be a number. So where it says a number, that's where our variable will go. Pick any letter you like. I'll choose N. So let's write it out. A number, that's N, decreased by, that's subtracting, 4, there's 4, is less than, that's the less than symbol, 14. So use the words in the sentence to write out your inequality. Since 4 is being subtracted, we'll add it to each side, and you get n is less than 18. So the final answer, all n, such that n is less than 18. Subtraction can be used to solve inequalities. If any number is subtracted from each side of a true inequality, then the resulting inequality is also true. So just like adding the same thing to each side, you can also subtract the same thing from each side of an inequality. Let's solve and graph each inequality. Number 1, t plus 12 is greater than or equal to 8. Well, the 12 is being added to the t, so let's do the opposite and subtract 12 from each side. That gives you t is greater than or equal to -4. So the solution is all t such that t is greater than or equal to -4. -4 is our important number. Since t is greater than or equal to -4, the -4 is included, so we put a closed circle. T is greater than, which is all the numbers to the right, and fill in the arrowhead because that will continue on to infinity. Closed circle on -4, shaded to the right. Number 5, 3r plus 6 is greater than 4r. Well, you have r's on both sides, so let's move them all to one side. Since 3r is smaller than 4r, let's move the 3r. It's a positive 3r, so let's subtract it from both sides. 3r minus 3r cancels on the left, leaving us 6. And then 4r minus 3r is r. Remember, you need the variable on the left, so let's turn this whole thing around. The mouth on the greater than is open to the 6, so let's keep it open to the 6 down here. R is less than 6. So the solution is all r such that r is less than 6. Remember, when you turn an inequality around, don't forget to turn the less than to a greater than or vice versa. 6 is our important number. R is less than 6. It's not equal to it, it's just less than, so that'll be an open circle on 6, and the lesser numbers shade to the left. Less than is an open circle shaded to the left. Number 6, 3/2 q minus 5 is greater than or equal to 1/2 q. Well, you have variables on both sides, so let's get them together. Since 3/2 q is more than 1/2 q, let's move the 1/2 q. It's a positive 1/2 q, so we'll subtract it from both sides. 3/2 q minus 1/2 q is 2/2 q, and 2/2 is just 1, so we have 1 q, or just q, minus 5, greater than or equal to 1/2 q minus 1/2 q is 0. Now move the 5. It's being subtracted, so we'll do the opposite and add it to both sides. You get q is greater than or equal to 5. So all q such that q is greater than or equal to 5. 5 is the important number. Q is equal to it, so it's a closed circle. And it's greater than, so it's shaded to the right. Solve each inequality. Number 7. 4p is greater than or equal to 3p plus 0.7. You have p's on each side, so let's move them to one side. The 3p is smaller, so let's move that one. Always move the smaller one if you can, because it makes it a little bit easier to work with. It's a positive 3p, so let's subtract it from both sides. 4p minus 3p is p. The p's cancel on the right, and it leaves 0.7. So you have all p such that p is greater than or equal to 0.7. Number 8. r plus 1/4 is greater than 3/8. The 1/4 is added to the r, so do the opposite and subtract 1/4 from each side. 3/8 minus 1/4, you have different denominators, so we need a common denominator. With 4 and 8, the common denominator would be 8. 3/8 already has an 8. 1/4 needs an 8. 4 times what is 8? Well, 4 times 2 is 8. So also do the numerator times 2. So 1/4 becomes 2/8. 3/8 minus 2/8 is 1/8. So r is greater than 1/8. All r such that r is greater than 1/8. Remember when you're adding and subtracting fractions that you have to have a common denominator before you can add or subtract them. Number 11. 4y is less than 5y plus 14. Well, you have y's on both sides. It's easiest to move the smaller one. The 4y is smaller than the 5y, so let's move it. It's a positive 4y, so let's do the opposite of a positive and subtract it from each side. 4y minus 4y is 0. 5y minus 4y is y, and we still have plus 14. Move the 14. It's being added, so let's subtract it from each side. 0 minus 14 is negative 14, and that's less than y. We need the variable on the left. The less than symbol is open to the y, so make sure that it's open to the y on the next line. The y first, and the inequality flips around. Now it's greater than negative 14. All y's such that y is greater than negative 14. Remember, when you flip the inequality sign around there, you have to do that whenever you move the variable from the right to the left. Define a variable, write an inequality, and solve. Number 14. The sum of two numbers is at most 6, and one of the numbers is negative 2. Well, the variable will be the number that I don't know, and we can use n. So, the sum of two numbers. I'm adding two numbers together. Look at the end of the sentence. One of the numbers is negative 2. And it doesn't tell me what the other number is that I'm adding. That other number will be my variable. The sum of two numbers, that's what I have now, is at most 6. At most is less than or equal to. It can't go over 6. It can be the numbers less than 6 or 6, but it can't go over 6, so it's less than or equal to 6. Now solve. I've got a negative 2 plus n. To move that, I'm going to have to add 2 to each side. Negative 2 plus 2 cancels out, leaving an n, and that's less than or equal to 8. So all n, such that n is less than or equal to 8. So when you're solving inequalities with addition and subtraction, remember, you can add the same thing to each side and you can subtract the same thing from each side. When you're graphing on the number line, make sure that less than and greater than have an open circle because the number is not included. Less than or equal to and greater than or equal to have a closed circle because the number is included. Less than shades to the left and greater than shades to the right. And make sure your final answer has the variable on the left-hand side. Your final inequality statement has to have the variable on the left.